So starting with page 7, I'm hoping you guys have been following along on your own notes. I recognize that sometimes this is a little hard to read on the video, but hopefully you can follow along with what I'm saying and use your own sheet. If you have lost your review packet, please check online. I'm placing another copy of it on there so that you can get on it and print out additional papers if you need them. Okay, so now we've talked about the electrons. We've talked about the organization of the periodic table. We've talked about the duet rule. Remember the duet rule for these first two, and everything else really is following the octet rule. And what that means is we need 8 electrons in the outer valence shell, but those 8 electrons are actually from the s and the p orbitals combined. So let's talk about the orbitals. We have an s orbital that is a spherical orbital, so like that. And in the s orbital, we have 1 orbital, but we can fit 2 spins. That means they can have 2. The p orbital, there's actually 3 p orbitals. And in the 3 p orbitals, we can then fit 2 in each, so 6. If you look at your periodic table, this is the s, and this guy here. But then all of these guys, they end in p orbitals. Anything in this region ends in an s orbital. These guys, all in this area, they are our d orbitals. There's 5 of them, and now we start getting even crazier, and so they look a lot similar, but we can end up with 5, so that's 10 electrons. And then finally, anything that's down here in the lanthanide and actinide series, they are going to end in an f orbital. So we can fit, summarizing, 2 electrons in any s orbital, 6 electrons in any p orbitals. D is 10 and F is 14. These two combine for the 8 rule, or the octet rule. All right, so now we have 2 different things that we can do for electron configurations and energy level diagrams. You've seen these linearly, but you can see them stacked, and this is talking about increasing energy level. And just check this out really quick. The S1 to 2, then 2p, more energy, 3p. But you notice you skip a little bit here. The 3d orbital actually comes after the 4s. And let's take a look and let's try scribbling in here our filling in the blank diagram. So we're going to number 1 through 6, and we're going to call all those our S's. Now we're going to start at 2, and we're going to go 2 through 7 there, and now these are all of our P's. And then 3, 4, 5, 6, 7, these are our D's. And 4, 5, 6, 7, these are our F's. And if you think, these go back to our periodic table periods 1, 2, 3, 4, 5, 6, 7. These guys get offset. This would be 3, 4, 5, 6, and these would be 5 and 6. So if we fill in, we're going to go through the 1s, the 2s, the 2p, the 3s, the 3p, the 4s, the 3d, 4p, and then just keep drawing your diagonal lines. So that, if they don't give you this, and they usually don't, you would need to fill it out and scribble it down. Sometimes, like on your last practice SOL, they actually gave you this. So sulfur, we need to look at a periodic table and find out where sulfur is. And let's see, I know these are hard to read. Let's get a blank, one of those not all shiny. And let's take a look here. So S, sulfur, is right there. So it is the 1, 2, 3rd period, and it is in 6A. So if we look back here on our this, it's going to be right about there. So we know, looking at this, it's going to have 2 p orbitals. Can you guys see that? It's on the second line in this group of p's. So we know that's where we should end up. But let's check it out. Let's see. Sulfur has an atomic number of 16, which means it has 16 electrons in the neutral atom. Please make sure, and I'm going to do an example that's not in your packet before we're done with this video, if you have an ion versus if you have the neutral atom. These are all neutral atoms. If you have an ion, you have to figure out, is it adding or subtracting, and then you tack those extra electrons on. So for sulfur with atomic number 16, has 16 electrons. We need to go through this until we're up at 16. So let's start with the 1s, and we can put 2 in there. Now we have put in 2 out of 16, so we're down to 14 left. 2s, we can put 2 in there. So out of the 14 we have left, we are now down to 12. Next is 2p, and 2p can fit in 6. So out of 12, I'm now down to 6 left. So you have to keep track of this. If it helps you to go, 16, okay, now I'm down to 14, okay, now I'm down to 12, okay, now I'm down to 6, then that's okay. So now 6, after 2p, we're going to 3s, and I can fit 2 in there. So out of my 6, I'm now down to 4. So now after 3s, I'll go to 3p, and I only have 4 left, and that does not fill it up, so we are done with that. To look at our diagrams, remember we have to put in one up arrow and one down arrow we fill. But we go through, let's put in all the up arrows for each number and letter before we wrap around. So for 1s, we're going to put in an up arrow, and then we'll put in a down arrow, because there's only 2. For 2s, we're going to put in an up arrow, and then we'll put in a down arrow. For 3p, we're going to put in 1, 2, 3 up arrows, and then we'll come back down and put in 1, 2, 3 down arrows to represent the 6 that I have. 3s, 1 up, 1 down. All right, 3p, I only have 4, so we are going to put in all of our ups, 1, 2, 3, and that only leaves me with 1 as a down. Always fill in your ups and then go back in and fill in your down. So that would be done for sulfur. All right, titanium. Titanium is a transition metal, and it's right here. So this is in the 1, 2, 3, 4, fourth period. This is in our D shells, but because the D shells always start one after, this would be, even though the fourth S is going to be the third D. Okay, so if this confuses you, what we do is we go right back to this chart. And we look and we say titanium has 22 electrons. Okay, so in 1s we put in 2, that leaves me with 20. In 2s we put in 2, that leaves me with 18. Now I go to 2p. 2p I can put in 6, so that leaves me with 12. 3s, 2, now I'm down to 10. So now 3s, I'm coming up to 3p. 3p, I can fit in 6. So now I'm down to 4. After 3p, right here, we go to 4s. 4s. And in s's, I can only do 2. So now I'm down to 2, and after 4s, I'm wrapping back around to 3d, and I can only put 2 in. And so by looking at our periodic table, we already knew that we would fill in a 4s, and we would be a little bit into the 3d. So if you want to put your arrows in, we can go ahead. All the ones that are full, you guys know that means they all have 2 arrows, 1 up, 1 down in each box. Everything is full until we get to 3D. So we can go ahead and put those in. But remember, we skip up to 4S And then we go back to 3D, and I only have 2, so I'm only going to put in 2 up arrows in 3D. All right, next one is gallium. Gallium's a little bit further down the periodic table, but it's in the same period as titanium. And now we're back in those P's. So 1, 2, 3, 4, we're in period 4. And we should end then at period 4 in a 4P. But we're also going to have this full 3D shell. So that means we're going to fill in all the way down to 4S, back to 3D, and over to gallium. Now, sometimes you're going to see this based on the most recent noble gas. So I could write this, instead of writing it all out, I could write something like argon and then go on from there. Oops, sorry, you guys can't see. So I could write argon and then go on from it. Let's go ahead and fill it in. And gallium has a periodic, let's see, it says an atomic number of 31. So 31 electrons. So 1s2, now I'm down to 29, 2s2, 27, 2p6, 21, 3s2, 19, 3p6, now I'm down to 13. Now remember, after 3p, we're going to go to 4s, and we can fit 2. And now we go to 3D, and the D shell has ability to hold 10. I've only got 9. Did I do that right? Let's check my math. It should be at a 4P. 31, so 29. Now I have 27. Put 6 in, 21, 19. 13. Oh, well, it's because 13 minus 2 is not 9. 13 minus 2 is 11. There we go. That makes more sense. So 11, now we can put in our 10. And then we have 1 left for going to our 4p1. But remember, argon is right here on the 1, 2, 3rd period at the end. So that means it's all the way to 3p. So if we look at this, from the beginning to there, that's argon. So sometimes you're going to see them right at argon, and then where argon left off, we will now finish and go after argon. We have that. It's just a very much more abbreviated way. We're saying we have the electron configuration of argon plus we have these extras. Okay, so to the arrows, remember we are all the way up to 4p and we're going to end with 1. You could just go ahead and fill in all those because you know you are totally full all the way up to there. And so just quickly going through, following good procedures, putting in all my ups, then my downs for each energy level. Or getting lazy and doing it the other way, but we know we're going to go all the way up to 4p1, so we're full up to there, and now 4p just gets 1, and then you're done. All right, so for the next video, we'll continue, but let's do an ion. Really quick at the bottom of the page, let's look at something relatively straightforward. Let's look at a fluorine ion. And we'll just write the number out because you guys know how to do that. So fluorine has an atomic number of 9. Okay, and it's way up here. So it's in group 1. And so let's talk about what that means. This is our 1s, helium and hydrogen of 1s. Lithium and beryllium, there are 2s. These guys are our 2p's. Fluorine is sitting here with 7 valence electrons. And I know that it's in period 7a or period 17, which lets us know 7. If it was an ion, it would either have a choice. Does it want to gain 1 electron or lose 7? Which one's easier? Well, gaining the 1 electron. So in a fluorine ion, instead of having 9 electrons, we're going to say it has 10 electrons. Any of your negative ions gain electrons. So now if you are going to fill that in, going back up here to your little chart, you're going to do the same thing. 1s has 2, so that leaves me with 8. 2s has 2, leaves me with 6. 3p has 6. Oops, 2p, excuse me. 2p has 6, and then we're done. The electron configuration of the ion is always the electron configuration of the nearest noble gas. So fluorine would go to neon. Matter of fact, all these guys are probably going to prefer to go to neon. But sodium's not going to want to go all the way over here to argon. Sodium is going to wrap back and go back to neon as well. So will magnesium. So these guys, sodium would lose 1 electron and would have the same electron configuration of neon. Magnesium would lose 2 electrons and have the same electron configuration as neon. If you have a question about electron configurations of ions, they always go to their nearest noble gas. All right, so next time we'll continue on, and we'll be moving on into unit, I believe we're still in a little bit in unit 3, but we're starting unit 4 and naming in the next video.